Hello viewers, this is a presentation of our running engine AA01. So this is the two-stroke engine that we are running on petrol, and it's a two-stroke engine which does not require oil. Let me repeat, this puppy does not require oil mixture into the fuel. And here is the cutaway. Basically we use this to get all the patents and basically things clear for our manufacturing. Now there are a lot of new things in this. First is that travel distance is only 90 degrees, meaning top dead center to bottom dead center is 90 degree. So it at 3000 rpm will have firing sequence of equivalent of 6000 rpm. So we have double the power stroke density compared to any engine. And here you can clearly see the pins are engaging. Teeth is just one of the core components out of the three components. So it's one roller, teeth, another roller, one roller, teeth, another roller. Teeth is never getting engaged without any support. Basically, it's a handoff from one pin to another teeth to another pin. So it's never unsupported or unconstrained. And this is the side view of the mechanism where you can see the roller action far more clearly and the offset axis that allows us to do turn around. Doing the turnaround motion was the most complicated part. That's why it looks so convoluted. And here we are running this puppy with a drill to basically increase the impact so people can easily understand what's going on. We had to cut it open, otherwise like people simply would not get it, no matter how much animation or video or even the running engine we showed them. So we had to actually give them to people hands, and then they're like, okay, we understand it, what's going on. As you can see, even at very high rpm it works, and we do not need very high rpm because piston strength is almost 2x of the rpm. So if you want to simplify, think in this way: for 3000 rpm we're gonna give you power stroke of 6000 rpm, 2x the firing density. So piston travel is actually much higher, but the shaft rotation is lower. Basically it's an inbuilt gearing system that allows us to get even more torque done. And here side view with drill power. So to maximize the roller impact, pay attention to the roller elements because there is no sliding element. And yes, you can see the top and bottom, but those are only for support. And in the full scale engine, those are oil bearings. So you do not even have to worry about any sort of rubbing actions. Basically it's fully supported by piston rings from both end. And since it's an over square engine, you can pay attention, it's not traveling that much. It's almost like a F1 engine kind of deal. So again, it was built more for maximizing the concept and people to understand what the heck is going on. So this is why we built this system. And here you can see the two stroke variant design, basically the port injection that is going on and the fueling system. So this is what we built, and we have completed the proof of concept. Now we are working on finalizing the full scale engine, which again, the engine is complete. We are now in the final phase of manufacturing. Once it's done, we're gonna do the final testing, and it all should be done in year 2025. So hope to see you guys once we are done with the testing. Thank you for your time.